Okay, so here we are. We're picking back up with chapter 3 in geometry, section 3. And in example 3 here, what we're asked to do is to determine whether line AB and line CD are parallel, perpendicular, or neither. And they give us 2 points on each line. So AB has the points 1, 1, and -1 and -5. And C has 3, 2, and D is 6, 1. I'm reading this out. Partly thinking, okay, so how do I tell them what to do? So I'm hoping you remember that when lines are parallel, their slopes, right? The slope of parallel lines are equal, right? Does that ring a bell? So like if the slope of this line was 5 and the slope of this line was 5, it would make sense that they have the same rate of change. So parallel lines have the same slope. I'll write that down. Okay, parallel lines have the same slope. And so now we need to talk about the slope of lines that are perpendicular. So when you've got two lines that are perpendicular, the slope of perpendicular lines, not really easy to say, they are opposite reciprocals of one another. So for instance, if the slope of a line is equal to A over B, then the slope of the line perpendicular would be B over A, the reciprocal, but the opposite reciprocal. So the sign changes. The sign changes and the thing flips. So with this in mind, parallel lines have the same slope, and then perpendicular lines have slopes that are opposite reciprocals of one another. I'll write that down. So as I said, perpendicular lines have slopes that are opposite reciprocals of one another. Now that we've got that clear, now we can really determine some information. So the first thing I need to do to figure out what the slope of line AB is, I need to do change in Y over change in X, that thing. So I'm going to just call like this my second point, my P2, and this my P1. Therefore, if this is P2, this is X sub 2, Y sub 2, this is X sub 1, Y sub 1. And again, I'm kind of going off the fact that I think you guys have seen this before. So -5 minus 1, if you feel like this is uncomfortable, let me know. As my numerator, change in Y over the change in X, -1 minus 1 down here. And so what I have at the top is a -6 and the bottom is a -2, and therefore my slope over here is 3. Let's check out what the slope of line CD is. And so I'm going to do the same thing. Let's call this first one 0.1 and this second one 0.2. Therefore, I'm going to do 1 minus 2 over 6 minus 3. Sorry for that little squiggle. 1 minus 2 is going to give me a -1, and 6 minus 3 will give me a +3. So I get a -1/3. Look at these slopes. They are not the same. They are certainly opposite reciprocals of one another. So I can determine from that these lines are perpendicular. Okay, so since we have that, we can now verify this situation by basically graphing the 2 points, right? Graphing not the 2 points, the 2 lines. Need to give myself a little bit of space here, and let me use black. I create an XY axis like so. Try to be as neat as possible. You guys have graph paper. Having graph paper is going to make your graph far neater than mine. However, I'll try. And so what I'm going to do, let me move this over a bit. What I'm going to do is try to use this graph to, ascertain whether or not we get what looks like a perpendicular line. So point A is at 1, 1. I'll put a little dot there. Point B is at -1, -5. So -1 down 5, 1, 2, 3, 4, 5. I'm down here for B. So here's A and here's B. And I'll try my bestest to draw a straight line. All right, that was something, I guess. Whatever, we'll just make the point bigger. All right, and then the next one is CD, and C is at +3, +2. That's right here. And D is at +6, 1, 2, 3, 4, 5, 6, +1 right here. And then so I would draw this, let me write the letters in there, CD, and I would draw this line as best as I can. And we, all right, not too bad. It is perpendicular, my friends. I know it doesn't look great, but that's how you would verify it. And of course, you would do a far better job because you've got graph paper. All right, so let's take a look at a couple of postulates here. Postulates about parallel and perpendicular lines. Slopes of parallel lines. Two non-vertical lines have the same slope if and only if they are parallel. So again, we get back to the idea. If you got two slopes that are parallel, non-vertical, so you know we're not talking about the up and down one, but we can talk about if the slopes of two lines are the same, we can say that they're parallel. So two non-vertical lines have the same slope if and only if. Remember the if and only if statement? That was that little side lesson I gave you guys. This is called a biconditional statement, meaning it can go either way. You can start with parallel lines and say that they must have the same slope, or you can start with same slope and say with the same slope and say they must be parallel. It goes both ways. So there's that. And then this next one, two non-vertical lines are perpendicular if and only if the product of their slopes is equal to -1. I like that. That was a slick way of talking about the opposite reciprocal. Let's think about how these two things dovetail and how they work with what I talked about. I said that two lines are perpendicular if one slope is a over b and then the other slope is the opposite, change the sign, reciprocal, b over a, right? What they're saying is this is true only if the product of their slopes is -1. Well, would the product of the slope be -1 in this situation? And we see that if we take a over b times -b over a, we do indeed get -1. So this is an equivalent way of saying that the slopes need to be opposite reciprocal. So I like this. This was slick. And with that in mind, I think we've come to the end of our wonderful time together. But let's go ahead and get through this example. We're going to graph the line that contains this point, A, which is at -3, 0, and is perpendicular to CD, where C is -2, -3, and D is 2, 0. So I actually kind of, copy the answer here. So I'm going to just talk about how we would get that answer. Well, first of all, it's really clear that we can graph CD, right? So we would find the points for CD. C is here at -2, 3, and D is here at 2, 0. Draw that line. Then locate the point for -3, 0. And now what we need to do is think about the slope of this particular line. Well, let's think about the slope of the original line. That slope says it is a rise over run. We go up from C, 1, 2, 3, and we run 1, 2, 3, 4. So the slope of this guy, let me do it in blue, is going to be 3/4, a positive 3/4. So what would the slope of the perpendicular be? Well, we just talked about if the line that we're talking about is A over B, then the line of the perpendicular one has to be -B over A. And so clearly the slope of this other line, let me do it in, I don't know, green, has to be -4 over 3, meaning drop down 4, go to the right 3. And that's exactly what they did here. They started at point A, they dropped down 4, they went to the right 3, and they came up with another point, and that point basically revealed a line for us, and there's our line. Does that make sense? All right, sorry for putting the answer out there before I actually talked about the problem. But anyway, I hope that makes sense. I hope you guys are feeling confident with the little refresher, the algebraic refresher about slopes. And I look forward to talking to you soon. I hope this makes sense. Take care, guys. Bye-bye.